Hello, this is Randy. Today we're going to do some more advanced multiplication of complex numbers. This is much like multiplying polynomials when we have variables like x or y, but today we need to remember that when we have the imaginary unit I that is raised to a power that is more than 1, then we can simplify that. Let's do this. So this is much like if we had two binomials that had variables, for example, like x and x right there. What do we need to do first? Well, we need to make sure that we multiply every term in this first expression by every term in this second expression. So let's do that. We'll start with this 2 right here, and we'll multiply it by 3, and then we'll multiply it by 5i. So 2 times 3 we know is 6. We have 6 right here. And then 2 times 5i, well, 2 times 5 is 10. We still have I, so 6 plus 10i, just like that. Now let's do this 4i times everything in this second expression. So first of all, let's see here. We have 4i times 3. So 4 times 3 is 12. So we have plus 12, and we still have that imaginary unit I. And now we have 4i times 5i, and that's going to give us a 20i squared. So we have 12i plus 20i squared, just like that. Now let's, even before we combine like terms, let's see if there are any imaginary units that have an exponent that is more than 1. In this case, you can see that we have an I squared right here, and we know that I squared is equal to -1. So let's replace this I squared right here with -1 immediately. And then we'll do some combining of like terms. So 20 times -1, just like that. We know that 20 times -1 is -20. So let's make this whole part of the expression just minus 20. So we're going to erase this -1 right here. We're going to make this symbol minus. Okay, beautiful. Minus 20. Okay, now let's combine all the like terms that we can. I see that we have a real number 6 and real number minus 20. So 6 minus 20 is going to give us -14. So minus 14 right there. -14. And then we still have a 10i and a 12i. Those are both imaginary numbers that can be combined. So 10 plus 12 is 22. So we have -14 plus 22i. And -14 plus 22i cannot be simplified anymore. So that is the simplified version of the original expression. Let's do one more example here. This time we have some more negatives, so it's going to be a little bit more tedious. So we have -4, and we're going to multiply that by 3 and then by -6i. So -4 times 3 is going to give us -12. We're going to write -12 right here. Now -4 times -6i will be a positive 24i. So we have -12 plus 24i, just like that. Now we're going to do this I times everything in the second expression, second part of this big expression right here. So I times 3, first of all, is going to be 3i. So we're going to say 24i plus 3i, just like that. And now we have I times -6i. That'll be a -6i squared. And hopefully some of you are thinking about the I squared being changed to -1, but we'll write here really quick. Minus 6i squared, just like that. And this I squared is -1. So let's replace that with -1. So minus 6 times -1. We know that 6 times -1 is -6. So it's as if we have minus -6. So let's do that. So we can say minus -6. And we know that minus -6 is the same as saying plus 6. So let's just write plus 6 right here. So we have 3i plus 6. And now that we have no imaginary units to an exponent that is greater than 1, we can start to combine like terms. So here we have a real number -12 and real number 6. So -12 plus 6 is going to be a -6. We'll write -6 right here. And then we have 24i plus 3i is going to be 27i plus 27i. And just like in the first example, here we also have the real number first and then the imaginary number second, which is, as we've discussed, the standard way to write a complex number. And negative 6 plus 27i cannot be simplified anymore. So that is the final simplified expression of what we originally had in the beginning. And with that, we are finished. See you next time.